Module 12 review, 12.1, page 182. It says write an explicit rule and a recursive rule for each sentence. So number one, let's write a recursive rule and explicit rule. Remember, for the explicit rule, it's the formula is f of n equals a plus d times n. Okay, or f of n equals a sub 1 plus d times n minus 1. That's for the explicit rule. Might want to put that on your 3x5 card. For the recursive rule, for the recursive rule, I might want to do it like this. For the recursive, we have f of 0 equals a, and f of n equals d plus f and then n minus 1. And that would be 4 n is greater than or equal to 1. And that's a comma and not a sub 1. All right, so write an explicit rule and a recursive rule for each sequence. First, we need to figure out a couple of things. We need to know what D is. And if you look, 12 minus 8 equals 4. All right, and check a couple others. 16 minus 12 equals 4. 20 minus 16 equals 4. So D is 4, not a problem. D is 4. Second thing we need to know is what is a. And since it has a 1 there, we're going to say a sub 1 equals 8. And we're going to use this formula right here for the a sub 1. F of n equals 8 plus 4 times n minus 1. And then for the other one, for the recursive rule, we're going to say f of 1 equals 8 and f of n equals 4 plus f of n minus 1. And that would be 4 n is greater than or equal to 2. Take a look at number 2 here. First, we need to figure out what is D. All right, D is 7 minus 11, that is negative 4. And 3 minus 7 is negative 4. So D equals negative 4, not a problem. A sub 1 is 11. So f of n equals 11 minus 4 times n minus 1. For the recursive, we would have f of 1 is 11 and f of n would be f of n minus 1 minus 4. 4 n is greater than or equal to 2. All right, not a problem. Not a problem. 3, get where I can scroll that up some, 3 would be, what is D? It looks like it's going to be 7. So f of n equals negative 20 plus 7 times n minus 1. That's the explicit. And the recursive would be f of 1 equals negative 20. And f of n would equal f of n minus 1 plus 7 for n is greater than or equal to 2. Number 4, let's see, what is D? 4.3 minus 2.7, I'm getting 1.6. All right, so f of n equals 2.7 plus 1.6 times n minus 1. And recursive would be f of 1 is 2.7. F of n would be 1.6 plus f of n minus 1. Now you can do notice I'm swapping back and forth. That's okay. 4 n is greater than or equal to 2. Number 5. So what do we got? We got 1 minus, or negative 8 minus 1. Negative 8 minus 1, that gives you negative 9. So D equals negative 9. Here equals D. And we've got f of n equals 1 minus 9 times n minus 1. And that's for the explicit. For the recursive, f of 1 equals 1. And f of n equals f of n minus 1 minus 9. 4 n is greater than or equal to 2. Not a problem. Go ahead and try 6 on your own. Stop it. Try 6 on your own. Glad you're back. F of n equals negative 3 plus 5.5 times n minus 1. F of 1 equals negative 3. And f of n equals f of n minus 1 plus 5.5. 4 n is greater than or equal to 2. Pretty easy, easy peasy. 7. Use the explicit rule for an arithmetic sequence is f of n equals 13 plus 6 times n minus 1. Find the first 4 terms of the sequence. So what do we got here? Let's use our calculator. We've got 13 plus 6 times 1 minus 1. All right, go up there and grab that. And we'll change that 1 to a 2. 2. And that gives us 19. Let's go up there and grab that. Change that 2 to a 3. And that gives us 25. And we need one more. We'll change that 3 to a 4. And that gives us 31. So our first 4 terms are 13, 19, 25, and 31. Helen paid back $100 in month 1 of her loan. In each month after that, she paid back $50. Write an explicit formula and a recursive formula that shows f of n, the total amount Helen had paid back by month end. So she paid back $100 in month one. So A sub 1 equals 100. What is D? Well, she paid back $50 in each month after that. She paid back $50. So D equals $50. So the explicit formula would be F of n equals 100 plus 50 times n minus 1. The recursive formula would be F of 1 equals $100 and F of n equals F of n minus 1 plus 50 for n is greater than or equal to 2. Number 9, the explicit rule for an arithmetic sequence is f of n equals 18 plus 5 times n minus 1. Write a recursive rule for the sequence. Okay, to do that, I need to know what A is. A is 18. What is D? D is 5. So I have f of 1 equals 18 and f of n equals f of n minus 1 plus 5 for n is greater than or equal to 2. Not too shabby. Not too shabby at all. Number 10, a recursive rule for the sequence f of 1 equals 7, f of n equals f of n minus 1 plus 47 for n is greater than or equal to 2. Write a recursive rule for the sequence. Not a problem. A sub 1 is 7. D equals 47. So my explicit rule is f of n equals 7 plus 47 times n minus 1. Not too bad, folks. Good job. Good job. Let's move on to number 2. What do we got here? Geometric sequences. We got some new formulas here. What are the new formulas? Let me scroll this up here like this, and there we go. So the new formulas, the explicit rule, explicit rule, f of n equals a times r to the n. And that's if you start at 0. If you start at 1, f of n equals a sub 1 times r to the n minus 1. Recursive. What's the recursive rule? F of, we'll say 1 is a, and A, there we go. And then f of n equals r times f of n minus 1. Okay? So let's take a look at this. What do we got? Each rule represents a geometric sequence. If the given rule is recursive, write an explicit rule. If the rule is explicit, then write a recursive rule. Assume that f of 1 is the first term of the sequence. All right, so let's take a look at 1. What kind of a rule is that? What kind of, looking up here, I'm seeing that looks to be explicit. That looks to be explicit, so I need to write a recursive rule. The recursive rule would be f of 1 equals whatever a is, and that's a, 11, and then f of n equals r, which is 2, times f of n minus 1. Yeah, that looks kind of, clear that up a little bit. F of n minus 1. All right, good job. Look at number 2. That looks to be a recursive rule, so that number 2 looks recursive. So we need to write we need to write an explicit rule for that. So f of n equals a would be 2.5 times, what is r? 3.5, and then n minus 1. Now over here, I didn't finish that. We started, what did I forgot? 4, n is greater than or equal to 2. All right, now let's take a look at number 3. What form is that in? It's in recursive. It is in recursive, so we need to write an explicit. F of n equals, a would be 27, r would be 1/3, and that's n minus 1. Looking at number 4, again, this one is explicit, so we're going to have f of 1 equals -4, and f of n equals, r is 0.5 times f of n minus 1. 4, n is greater than or equal to 2. Cool beans. Let's try number 5. Write an explicit rule for each geometric sequence based on the given terms of the sequence. Assume that a common ratio r is positive. Okay. So what do I got here? I got 360. So r will equal 360 divided by 90, which is 4. And I'm supposed to write a recursive rule, so I have f of n equals 90 times 4, and it's n minus 1. All right. Let's take a look at number 6 here. R equals 4 divided by 16, which is 4 divided by 16. I'm getting, what is 4 divided by 16? I'm getting 4 divided by 16. I'm getting 1/4. So 1/4. F of n equals 16 times 1/4 to the n minus 1. Ah, yes. So here I have, that's a to the 5th. A to the 5th. So, I may need a little real estate here. Let me get a little real estate here. I may need a little real estate. So I'm sitting here looking at, first term is 2, and then we got 3, we got 4, 1, 2, 3, 4, and then 5 is 162. How am I supposed to find that? I'm missing 3 terms here. Okay, well, let's see here. We've got our trusty formula, f of 1, 2, 3, 4, 5. F of 5 equals 162. So how that formula was f of n equals a sub 1 times r to the n minus 1. So if so this is going to be 162 equals 2, and then I got r, and that's going to be 5 minus 1. Well, if I divide both sides by 2, that gives me 81 equals r to the 4th. Okay. R to the 4th. What to the 4th power equals 81? Let's see here. 3 caret 4. There's 81. Good deal. So 3 to the 4th equals r to the 4th. We've got the same right there. So 3 equals r. Okay. If 3, and just for giggles, 3 times 2 is 6, times 3 is 18, times 3 is, what is 18 times 3? 18 times 3 is 54. 54. And if we multiply that times 3, that gives, yes, 162. Is that what we, that worked out perfectly. So our equation is f of n equals 2 times 3 to the n minus 1. Easy peasy. A sub 2 is 30, a sub 3 is 10. Well, what is r? R equals, and that would be 10 divided by 30, which is 1/3. Okay, so if 1/3, how do we backtrack? Well, let's see, if a sub 2 equals 30, all right, so we got 30 equals, we don't know what a sub 1 is, but we know that r is 1/3, and that's for 2, so I got 2 minus 1. Well, 2 minus 1 is 1. Multiply both sides by 3, and I get 90 equals a sub 1. All right, so f of n equals 90 times r to the n minus 1. Doing good, folks, doing good. Yes. Roll that up. Let's see, that was number 9. Let's see, number 9. Oh, this is, look at here. What are we doing here? All right, so what is, well, let's see here. We're going to have to find some stuff out. We got a to the 4th. And 8. Well, so we got 405 divided by 135. And we're trying to find r. So what is 405 divided by 135? And what do we, 3, okay? So r equals 3, okay. We got to backtrack a little bit. So a sub 4 equals 135. So a sub 3, well, 135 divided by 3, 135 divided by 3 would give us 45. 45. And then a sub 2, 45 divided by 15. A sub 1 would be 15 divided by 3 would be 5. All right, so we have f of n equals 5 times 3 to the n minus, well, hold a second, Mr. Carpenter. Are you sure this works? Well, we got a sub 5 is 405, right? So let's put 5 in there. What do we got? That's our equation. We got 5 times 3 caret, and that was 5 minus 1. And we're hoping for 15. Oh, look what I did, 5 minus 4. That was silly. It was supposed to be 5 minus 1. Whew, that worked out. So it does work. Okay. All right. Okay. So let's take a look at 10. So we got a sub 1, a sub 2, a sub 3 is 400. A sub 4, and then a sub 5 is 256. Wow. How are we supposed to find out what's going on here? So what is happening? What is happening here? So we got 256 divided by 400. What do we got here? 256 divided by 400. That's 16 over 25. 16 over 25. Wow. 16 over 25. 16 over 25. That equals 16 over 25. Okay. Are you seeing something there? 4/5 maybe? Because it happened twice, right? So 400 times 4/5 is what? 400 times 4 control divide 5. That's 320 times 4 control divide 5. Ooh, 256. That's what we were looking for. Okay, so 4/5. Huh. All right. So we got, well, we can put, let's see here. We got 320 goes in here. 320. All right. Now we got to find this one here. We found our R. R equals 4/5. Okay. So if we got 400 equals, and we don't know what a sub 1 is, and that's R, which is 4/5. 4/5. And then this is the third term, so that would be 3 minus 1. Well, 3 minus 1 is 2, so we got 2. So what do we got here? 4/5 squared. Well, what is 4/5 squared? That would be 400 equals a sub 1 times 16 over 25. So we multiply both sides by 25 over 16. So 400 times 25, control, divide 16, and that gives us 625. So 625 equals a sub 1. Okay. So I multiplied both sides by 25 over 16. And it's 25 over 16. So we got 625 is a sub 1. So f of n equals 625 times 4/5 to the n minus 1. Is that not cool? That is cool. All right. Number 11. So a sub 2 is 80, and a sub 5 is 10. A sub 4 is, just 10, just 11 for now. That's number 11. Okay, what do we got? Number 11. Well, let's see here. Let's draw it out so we can see what we got. All right, you got a sub 1. A sub 2 is 80, a sub 3, a sub 4, and then a sub 5 is 10. Okay, so let's see here. 10 divided by 80 would be 1/8. And we went 3 places. So I'm thinking 80 times, let's see, so R equals 1/2. 80 times, that would give you 40, that would give you 20, and then that would give you 10. All right, which means this right here would be 160. So f of n equals 160 times 1/2 to the n minus 1. Number 12. Oh, wow, look at this. 1, 2, 3, and then 22, 4, 5, 6, and then 0.022. You seen a pattern there? All right, so let's see. We got 0.022 divided by 22, and that's like 1/100th or something. 0.022 divided by 22. 0.0, is that 001? 0.001. Okay, and that's a 1, 2, 3, 4. 1, 2, 3. Okay, so let's try this. 22, and then if we used R equals 0.1, that would give you 2.2, 0.22. That didn't work out right, did it? Let's see, that's 4, 5, 6, 7, 4, 5, 6. That was supposed to have been right there. That's why. Okay. So that did work out. I put it down here, 0.022. All right. So that did work out, 0.1. So f of n, hold on, we don't have a sub 1. So what are we doing? Let's add, and then what do we got? That would be 220, and then let's see, then multiply that back. That would be 2,200, and that would be 22,000. Okay, so f of n equals 22,000 times 0.01, and it's n minus 1. Well, hold on a second, Mr. Carver. I'm sitting here looking at this. How in the world are you doing that? I'm multiplying each one of these by 10 to what's the opposite of 0.1? 10. Okay, and let's see here. All right. A bank account earns a constant rate of interest each month. The account was opened on March 1 with $18,000 on it. On April 1, the balance in the account was $18,045. Use this information for problems 13 through 15. So let's move that up a little bit. All right, let's see what we got here. What do we need? What a bank account earns, and let's see here. Well, it's just a simple interest, right? For 1 month, not a problem. Okay, so for the first month, and then let's see, it earns a constant rate of interest. Well, we don't know what that is. Okay, well, let's see here. 18,000, and let's see here. $18,045 divided by 18,000, and that gives you, control, 1.0025. So there's your interest rate, 1.0025. So R equals 1.0025. And then let's see, A sub 1 is 18,000. All right, and write an explicit rule. So f of n equals, I'm about to write an explicit rule. Okay, so f of n equals, that would be 18,000 times 1.0025, and that would be n. All right, n minus 1. Let's use that. And then a recursive rule would be f of 1 would equal $18,000, and f of n would equal 1.0025 times, let's write this right, times f of n minus 1. And that would be 4, n is greater than or equal to 2. Find the balance after 5 months. So how am I going to find the balance after 5 months? How am I going to do that after 5 months? Well, let's see here. How about f of 5 equals 18,000, 1, 2, 3, times 1.0025, and then 5 minus 1. What does that give me? Let's try that. 18,000 times 1.0025 caret, and that was 5 minus 1, so we'll just put 4 there. And then we get $18,180 and we got to round up 68 cents. So we got $18,180.68. What about after 5 years? Well, How many months are in a year? 12 months times 5 would be 5 years and 12 months. I'm getting 60. So what do we got here? F of 60 equals 18,025, and then 60 minus 1. So let's see here. I'm going to go up there and grab that, and I'm going to change that 4, let's see, caret to 59. And I get $20,856. So I get $20,856.96. Yeah. All right. Good job on number 2. 2/3 of the way. Oh, geometrics. Now it's time for some fun. Determine the values of A, N, and R for each geometric series. Then use the summation formula to find the sum. Okay, we were doing that sum today, wasn't we? All right, so what is A? A equals 1. What does R equal? Well, let's just go ahead and do N. It said N second, so N is 1, 2, 3, 4, 5. So N is 5. And R equals 6 divided by 1, which is 6. Okay. So what is the sum? S of 6 equals, and then we got 1 times 1 minus 6 to the 5th power over 1 minus 6. All right, let's put that in the old calculator there. What do we got? 1 times, open parentheses, control, divide. 1 minus 6. Oh, I did 5 there, 6. Caret 5 over 1 minus 6. 1 minus 6. And I got 1555. 1555. All right. Number 2. A sub A is 2. N is 1, 2, 3, 4. N is 4. And R equals negative 12 divided by 2. And that equals negative 6. So let's see. S sub 4 equals 2, and that's 1 minus, that's negative 6 to the 4th power over 1 minus, that's negative 6. And you should get negative 370. Negative 370. What about this one, right? Well, these are all straight negative, so R is going to be positive. A is negative 1. N equals 1, 2, 3, 4, 5. N is 5. And R equals negative 4 divided by negative 1 is just 4. All right, so S sub 5 equals, and let's see, negative 341. See if I got that right. 4A is negative 4. N equals, that's 1, 2, 3, 4, 5. N is 5. And R equals 8 divided by negative 4, which is negative 2. So S sub 5 equals, and your answer should be negative 2. All right. Good job. Determine the number of terms in each geometric sequence. All right, number 5. Determine the number of terms in each geometric series, then evaluate the sum. So we got, this is 1, 2, 3, and we need to figure out what that one there is. Not a problem. Let's get us a little real estate here. And so we have 46,875 equals, and then A would be 3. Well, what is R? Well, let's see. R equals 15 over 3, which is 5. So that's 5. And then we have N minus 1. So let's divide both sides by 3. And 46,000. Let's see here. 46,875 divided by 3, 15,625. So 15,625 equals 5 to the n minus 1. All right, so let's just play a little guessing game. We'll say 5 caret, and we'll try 8. Oh, overshot it a bit, right? Because I'm looking for 15,625. Overshot it a bit. So 5 caret 6. There it is. So, all right. So 5 to the 6 equals 5 to the n minus 1. I have the same basis here. So I have 6 equals n minus 1. So n equals 7. So this is the 7th term. All right. So n equals 7. Next, I need to figure out the sum. All right. So S sub 7 equals 3 times 1 minus 5 to the 7th power over 1 minus 5. So what do we got here? 3 times open parentheses, control, divide, and we have 1 minus 5, I think it was the 7th power, over 1 minus 5. And what do we got? 58,593. So S sub 7 is 58,593. All right. Cool. So here we need to, this is 1, 2, 3, and we don't know there. All right. So F, let's see here. 1,458 equals A sub 1, and then we R. Let's see, R equals, that's negative 6 over 2. That gives me negative 3. So that's going to be 2 times negative 3 to the n minus 1. Divide both sides by 2. I got 1458 divided by 2. 1458 divided by 2. 729. 729 equals negative 3 to the n minus 1. So that's positive, right? Okay. So 700. Let's see. Negative 3 caret. Let's try 5. Ooh, so it's going to be 6. Negative 3 caret 6. There it is, 729. So negative 3 to the 6 equals negative 3 to the n minus 1. Cancel out those. And I got 6 equals n minus 1. So n equals 7. S sub 7 is, and this time we have 2 times 1 minus negative 3 to the 7th over 1 minus negative 3. And what does that equal? Let's try. We got 2 times, open parentheses, control, divide, 1 minus, and then negative 3, close parentheses, 7. Ooh, caret 7. And then on the bottom, we have 1 minus negative 3 and 1,094 equals 1094. All right, good. 7. So what do we got here? Let's see here. We're going to have to do what we've been doing, hadn't we? Let's keep up the good work then. And 1, 2, 3, and we don't know what this is, so n equals, and we got negative 78,125 equals negative 1 times, and I'm thinking 5. How did I get that? To the n minus 1. How did I get that? R equals negative 5 divided by negative 1, which is just 5. All right, so there we go. And that's a 1. And so we divide both sides by negative 1. We got 78,125 equals 5 to the n minus 1. Didn't we do something like that a while ago? 5 caret 10. No, 5 caret 8. 390,000. What are we looking for? 78,000. So we're 5 caret 6. 15,625. Ooh, 5 caret 7. 78,125. 78,125. That is 5 to the 7th. So 5 to the 7th equals 5 to n minus 1. Cancel the bases. 7 equals n minus 1. 8 equals n. So n equals 8. N equals 8. All right. So let's see here. S sub 7 equals, and that's going to be negative 1 times 1 minus, that was 5 to the 7th power over 1 minus 5. Is that right? That was 8. Where did I get 7 from? 8. All right, and that should equal negative 97,656. And let's try this one here. So let's see, R equals negative 16 divided by negative 4, which is 4. So we got negative 262,144 equals negative 4 times 4 n minus 1. Negative 262,144 divided by, what was that? Negative 4. Negative 4. And I get 65,536. 65,536 equals 4 to the n minus 1. Now, I'm going to cheat a little bit. And remember this. Menu 3, 1, and then we'll just put in negative 262,144 equals, and then what we have negative 4 times, and then we got open parentheses 4, close parentheses, caret n minus 1, and then comma n, and we got 9. All right, so n equals 9, and then s of 9 equals negative 4 times 1 minus, and that was 4 to the 9th power over 1 minus 4. And what does that equal? Negative 349,524. All right, let's take a look at number 9. A geometric series begins with 4, ends with 1 over 64, and has terms that successfully decrease by half. Okay. Evaluate each geometric series described. Okay, it begins with 4. So we got, let's see, we got 4, and let's see here. And it begins with 4 and ends with 1. So 4, and then we got several, and then we got 1 over 64. All right, and has terms that success. So 4, and then that would be 2, and that would be 1, and I'm thinking that would be 1/2, and then 1/4, 1/8, 1/16, 1/32, and then 1 over 64. Okay. So let's see here. How many terms is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So S of 9 equals, and then it started out with 4, so we got 4 times, open parentheses, control, divide, and we got 1 minus, and then what was R? What was R? R was 1/2, so we got open parentheses, 1, control, divide, 2, and then caret 9, I think it was. That was 9, wasn't it? 1, 2, 3, 4, 5, 6, 7, 8, and N is 9. And then that's over 1 minus 1, control, divide, 2. All right. So we got 511 over 64 equals 511 over 64. Good deal. A geometric series also n equals 9, starts with -2, so a equals -2, and has a common ratio of -4, and r equals, well, that just made it easy. So S of 9 equals -2 times 1 minus -4 to the 9th power over 1 minus -4. And what does that equal? I think -104, 858. All right. Deanna receives an email asking her to forward it to 10 other people. Assume that no one breaks the chain and there are no duplicate recipients. How many emails are sent after 8 generations? How many are sent after 8 generations? So n equals 8. A sub 0 equals 1. R equals 10. See, okay, so let's try that. So we have 1 times, open parentheses, control, divide, and we have 1 minus 10 caret 8 over 1 minus 10. Wow. Okay. That's going to be fun, right? So S sub 8 equals 111, 111, 111. That's a lot of folks. Good job, folks. See you tomorrow in class. Good luck on the test, and have a great evening.